friends, we'll solve problem on kinematics of rigid bodies. Let's see what is given in this problem. Locate instantaneous center of rotation of link AB. Find also angular velocity of link OA. Take velocity of slider B equal to 2500 millimeters per second. The link and slider mechanism is shown in figure. Now in this mechanism, number of links are given as 2. One is OA and other link is what? AB. Link OA rotates about fixed center of rotation, which one is hinge support here. That means link OA or rod OA performs pure rotational motion. But link AB doesn't rotates about fixed center of rotation. That means link AB performs general plane motion. What data is given in problem? That linear velocity of slider B is 2500 mm per second. Its direction is also given in figure, that is 2500 mm per second. That means if we'll write in meters per second, this VB is equal to 2.5 meters per second. Now as VB is along the plane inclined at 30 degree in upward direction, rod OA has to rotate in which direction is important. As VB upward, point A has to move in upward direction, and as link OA performs pure rotational motion, linear velocity of point A must be perpendicular to OA. Therefore, if we draw perpendicular to OA, we will get a vertical line. As VB upward, VA must be again upward, but this must be perpendicular to OA. So for AB, now center of rotation means ICR, if you want to represent, will draw perpendicular to VA and perpendicular to VB. Perpendicular to VA, if we draw, we will get a horizontal line where you don't know where is the ICR. And now if we draw perpendicular to VB, if we represent perpendicular to VB, so I will draw here line. Which one is perpendicular to VB? So you will get what? Such a line, and point of intersection represents center of rotation. Say this point is I. This line is perpendicular to VB. Now you have to find out what is the length IB and IA. Without that, solution is not possible. To find out IB and IA, as this angle is 30, this one is 90, that means with horizontal what angle we will get is what? 60. That means IB is inclined at 60 degree with horizontal. That means can you say this angle is what? Again here 60 degree. This angle is 60, this 90. That means this angle at B is what? 30 degree. Now in this triangle IAB, you know length AB equal to 400 mm. All angles you know. That means using sine rule in triangle IAB, easily we will get IA and IB lengths. Once we will get I and IB, using VB equal to I into omega AB, we will find out omega AB. Once we will get omega AB, VA equal to IA into omega AB, we will find out VA. Now point A is common point on link AB and OA. Therefore, for link OA, if we use equation V equal to R omega, that is for point A, VA equal to OA into omega OA. As you are getting your VA upward and it rotates about point O. That means for this link OA, direction of omega OA will get again clockwise. For link AB, as it rotates about this point I, direction of omega of AB also clockwise. It means next step is what? In triangle IAB, using sine rule, we'll find out lengths IA and IB. Represent on next page. Just see here. In triangle IAB, using sine rule, you have to find out IA and IB. IA upon sine of opposite angle. Opposite to IA, sine is angle is what, 30 degree, therefore sine 30. Next, IB length divided by sine of opposite angle. Opposite to IB is 90 degree, that means sine of 90. And third length is what, AB, where length AB is given in mm, 400 millimeters. We'll substitute here in meters, that is 0.4 upon sine of opposite angle to this AB is what, 60 degree. Now if you calculate using calculator, this one will get as what, IA equal to sine 30 into 0.4 divided by sine 60. That means IA comes out to be 0.23 meters, and IB equal to sine 90 into 0.4 divided by sine 60. That means this IB comes out to be 0.46 meters. As you are getting I and IB, we'll apply now equation V equal to R omega for link or bar AB. For bar AB, linear velocity of point B is known, therefore we'll use equation V equal to R omega for point B. VB equal to distance of point B from center of rotation, that means IB, into omega AB. What is known, VB is 2.5 meters per second, length IB is 0.46 into omega AB. Therefore, omega AB comes out to be, if we find out using calculator, omega AB is 5.43 radians per second, direction of omega clockwise. Once we will get omega AB, next point on link is what, VA equal to its distance from center of rotation into omega AB. What is known, IA is known, IA is 0.23, omega AB you have calculated for 5.43. That means VA, if you calculate using calculator, comes out to be 1.25 meters per second, and direction of this linear velocity is upward. So using equation V equal to R omega for AB, you are getting omega AB and VA. Next for bar, next bar is OA, and point A is end of bar OA, therefore VA equal to distance of point A from center of rotation is point O, therefore radius of rotation OA into omega OA. Therefore what will get here, VA will substitute 1.25, OA length is given in mm as 200 mm, that means this one in meters is 0.2 into omega OA. Therefore omega OA comes out to be 6.25 radians per second, and its direction of omega again is clockwise. What is asked in problem, omega AB is what, so that is 5.43 radians per second clockwise. Omega OA is what, it is 6.25 radians per second in clockwise direction. Thank you.